All right, day 8. Resonant collinearity. Oh my god. You find yourself on the roof of a top secret Easter Bunny installation. Another reference. Yeah. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. EBIM. EBIMC. 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 No, I thought I was missing a trick there. Anyways. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit to create a map. Okay. So we have this. The signal only applies its nefarious effects at specific antinodes based on the resonant frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency. So OPS still going? Yep. There are two antinodes on... Wait. But only when one of the antennas is twice as far away as the other. Okay, so a third and then 2/3 along. This means that for any pair of antennas with the same frequency, there are two antinodes on either side of them. So for these two antennas with frequency A, they create the two antinodes marked hash. Okay, adding a third antenna with the same frequency creates several more antinodes. We would ideally add 4 antinodes, but 2 are off the right side of the map, so it only has 2. They create 2 antinodes marked hash. So there are okay. So for these two antennae with frequency A, they create 2 antinodes marked hash. Interesting, okay. They don't seem to create them. Should they create them on like away from each other? They could create them in between, right? Adding a third antenna with the same frequency creates 7 more antinodes. It would ideally add 4 antinodes. But 2 are off the right side of the map, so instead it adds only 2. So okay, this one, that one creates that antinode, and then one on the bottom right there. This one, that one creates this antinode. Okay. Okay, so it kind of looks like a maths problem. Well, it is a maths problem. So we can start off with this. This one here, removing the hashes. We could calculate the... Yeah, I think this is actually like pretty fine. The only, I think Eric, the creator of AOC, probably is nice enough to not give you decisions as to where to round, but I could be wrong there. Okay, so we take for every A, we check on other A's. That's where the antinodes are. Let's start with this. And now we can progressively add more complexity. I'm gonna add dot here. Okay. Okay. So let's go. Type equation equals M. No, hold on. So we need a given 2. Okay, let's just start with the gradient. Oh, sorry. gradient. So it has a x and a y, x1, y1, x2, y2, which is equal to y2 minus y1 over x2 minus x1. Let's get coordinates. Get coordinates given lines equals let recursive loop that takes in ACC and lines, match lines with empty, returns ACC, else head tail string dot falls left. Function ACC C if C equals frequency, then we return I oh wait, hold on, we need to, is there a fold left that has, oh no, let's go then index and ACC. So then we can return I plus 1 always, and let's up here give it the y, so we go I and then y at, sorry, concatenated with ACC, else we just return I plus 1 ACC, we give it a 0 and this, I think fold left, what we want to do here as well is actually just go ACC and this and head and loop or pipe this into loop. Nope, sorry. We want to go we do this and with a head and actually string the loop. Oh no, I'm actually being stupid. Hold on. Let's separate this out. Let row chords equals this. That is an int times wait, that's not right. Oh yeah. Okay. In row, let's go. Why am I struggling? I'm struggling. I just want to do a loop of row ACC and row chords, right? Oh, list.map and I underscore and then chord, and we just map to chord, and we pass this in the row chords y and tail. loop. You see it's just an empty list. Y starts at 0 and then lines. Oh my god, what's that? Mm-hmm. So you should be an int. What is this? Oh wait, I need to wrap this in brackets. No, I don't. Let's go row only. Let's pipe this into list.map this thing. I don't understand why that's doing that. I wonder if, I hope it knows what I mean there. Mm-hmm. Oh, wait. That's the one. Okay, so I don't need to know. That's because I sent as a tuple. And the other part is the list. So we loop with ACC and chords. Cool. Let's do lines here. Let's just test equals. Get coordinates of lines. The char is A in list of length of test 0. Let's just see if we get 2. Okay. And let's print list dot nth of test 0. This is going to give us a let's like xy equals list dot nth of test 0 in x y. Well, that doesn't look right. That might be it. And now it actually knows no need for that. The first one is 4, 3. X 4, 3, so it's going to be y 0, 1, 2, 3. 0, 1, 2, 3, 4. Okay, cool. It's working. It is working. We'll start with this and let m equals gradient of, so list.nth test 0, list.nth test 1 in m 2. The gradient is 2. Oh, it's 2, but it's all reversed. Okay, I need to keep, I'm just gonna write myself a reminder. Gradient signs are all reversed because y going down is plus. That makes sense to me. And it is 2. Let's double check. 1 for every 1, we got 2 down. Great. So then what we have to do is we have to figure out the distance. That distance, that's this equals distance from one to the other is oh, so yeah, okay. It's x2 minus x1 squared, Ocaml power operator, integer explanation in Ocaml. There's no way that this doesn't exist. Math operators. Exponent, no. Really? Like, actually? No way you don't exist. I don't understand a library, you can easily write your own. So weird. What about Ocaml square root? There is such thing, right? Square root, how? Just, I don't know, man. I find it kind of weird that we don't have this here. Okay, let's write an exponent function. Let's go. Oh, whoops. Okay, still going. X to the power of n equals let recursive loop x n equals match n with 0. ACC, otherwise ACC plus n times n, otherwise literally any, plus loop of do we just do, actually we do loop of is c plus n times n and n minus 1 in loop 1 x n. Oh wait, no. I don't need x there to be fair, I can just, but I can do x times x. There we go. Let's just like really be foolproof about it, I guess. Let p equals exponent of 5 and 2 in p. Let's try that. $51. Wait, so no, it's just ACC times x. I know we keep going down. Oh no, what have you done, bro? Just stop doing stupid shit like this. Why? Loop 1 n. There we go. 25, great. Now 125. Yeah, cool. Now the distance is equal to exponent of it's going to be x2 minus x1 2 plus exponent of y2 minus y1 2 square root of the entire thing. Nope. What do you... Oh, come on. If int was expecting a type float. Okay. Float of int. And let's go int of float again. There we are. That's all good. Let's just type in the distance is equal to the distance between test1 0 dot n test1. Two. No, it should be. Is it 2? 1, 2, 4, 5, 5. Maybe we don't actually care this much about like actual individual distances. Yeah, I think we distances, so we don't have to square. We do have to square root things, but not entire things. Let x distance equals x2 minus x1 2 let int square root. No, one. Oh no need to square roots. Ocaml abs operator. Positive value function Ocaml. Okay. It feels so weird that I don't have these in the standard library. Let's abs x equals if x is smaller than 0, then minus x, else x. we actually just do this. Exponent y2 minus y1, 2 into ABS. Distances. Okay, I think we're being quite slow to them. Well, I'm being quite slow today, but that's maybe fine. No need for exponents anymore. It's just that. It's just that. This doesn't look, that doesn't look correct. Wait, what? Oh, wait. What happened here? Oh, come on, why? What happened? Okay. Oh, I deleted that function is gone. Well, I didn't delete it. The autocomplete insists on deleting it. Can you leave my function alone, please? Doesn't wanna. What? There you go. Fine. Whatever the hell that was. Okay. We have this, so then we have to find the extremities, which way it goes, and then place the thing. So there's two ways you can go: down to the right, top to the bottom, top left to bottom right, or top right to bottom left, depending on if the gradient is positive or negative. So we need to get the smallest. Oh wait, hold on. This is gonna be a little bit tricky. I don't want abs at all. Abs should not be a thing here. Because we're gonna get a little bit of conflicts. Well, in some ways. Distance from. Okay, so what if we do this? It's 1 and 2, so it goes from the top left to bottom right. So we just have to be a bit careful, I guess, and kind of drive this one here. So what we could do is we could do the let x y equals list dot nth test 0. So I'm going to do x plus 2 times the distance, y plus 2 times the distance. Oh, I'm so pissed off with my setup right now. Alright. Do I not have no less enabled? Okay, sure. 6, 7, that's XY, so 7 is going to be actually 8. And then 6 is actually going to be 7, so it's going to be down there. That's correct. And then the other one is going to be the minus of that. Okay. We should be careful. Get anti-nodes for x1, y1, x2, y2. Let m, let dx, dy equals distances of C1, C2. And we're going to return two antinodes, which is best represented as a tuple, I think. We're going to go x plus 2 times dx, y plus 2 times dy, x minus dx, y minus dy. Okay. Now the problem wants me to do this for all of them. Wait. What's this? Because the topmost A frequency antenna overlaps with a 0- frequency antinode thereof. Because the topmost A frequency antenna overlaps with a 0 frequency antinode, there are 14 total unique locations that contain an antinode within the bounds of the map. Okay. I mean, isn't that just... Oh, that's part... Oh, wait. I've kind of really overcomplicated part 1. I really hope we need this for part 2. Let's get pairs, takes in lines. So let's get frequencies, takes in lines. We could do a set here. F char. Char set. We have the set and we have the lines equals match lines with this returns the set, head, tail. Let string dot fed left. Let chars string dot fed left. If c is not equal to dot, then c and AC, also ACC. and we apply to set. List.iterate. See char set dot add. This is going to return a set there. Fold left. C returns char set dot add C ACC. We return char set dot empty, and we return chars. Let new set equals, and let's make sure that that is what I want. So that's the set with, oh, it's not the empty set though, it's going to be the set, and then we go with loop, new set, and tail. Okay. Oops. Char set dot to list of loop, char set dot empty, and lines. Now this returns a char list. Now all we have to do is find all of the pairs of these so I kind of want a list. We have a bunch of characters, but we actually need to know. We need to know more things about these. Yeah, we need to know quite a bit more. So I actually want to know. I want to create a map. Yeah, I need a map. And I made a map somewhere here. Kind of. So it's going to be a char map that maps to the, some tuples. Let's make those. Sure. Okay. So yeah, I don't really want to set at all. So what we're going to do is we're going to go chars so we're going to have to also keep a y. Yeah, let's ignore that there for now. That returns map. that returns an index and a char list. No, but I don't really, if it's not equal to this, then I actually want to return oh, come on. I want to go through each one, give me the coordinates and what you actually are. Alright, it's been a day. That was just life got in the way a little bit, so it's kind of a weird break in the video. But we're going to try and finish yesterday's day, which is day 8. So I remember where I was left off. I was trying to get frequencies from lines given not a set but actually a map. So I'm going to need a char map down here. So given those chars, if it isn't this, then we actually return something else. Let new chord equals to x, which is going to be I, and then y. Let's get rid of that. Does it know what? Doesn't really know what map is. So let's do what did I call it? Char map. Char map dot put add what does it take in? It takes in the map, and it's going to take in new chord, or actually it's going to take in C chord, new map equals this, key date map in. Okay, so does it know what you are? C. When did I make a map before? Yeah, int map. Maybe I can have anything returned. The functor to create function, refer to functors. String map module has an empty A. So actually it's not char map. You know, it is going to be char map. This is char over here. And then we're going to do the accumulator for this here is going to actually just be new map, else just map. Char map dot empty. Hold on. So we have this. We have this, the accumulator head, and then we go in. We have chars, and we go loop y+1 of and we return loop of 0 char map dot empty. oh, actually, this here is the map. And lines. Okay. That's we're still getting really weird formatting stuff going on. Okay, something like this. Okay. So you take in a string list, you return int charmap.t. I think that's right. Great. So now what we have to do is, what's our input? A's. Oh yeah, A's only. Let m equals get frequencies of lines in. Let my a equals, oh, that's a bad one. Charmap dot let's actually just save and come back. Okay, you can go. Dot find the char a m. Oh, you should be a list actually. Ah, okay. Existing chars equals charmap dot find option. Find objects in C. Match existing chars with none, then okay, so this will have to, oh yeah, brackets for this. There we are. So now that's actually a list. Nice. I can go test let first C equals list dot nth of 0 test in, or yeah, it's the other way around, I always get it wrong. XY. Alright. Not found. ACC, which is from here. Then we're folding on 0 a map there, the head, and then we're looping starting at 0 with charmap.empty and then lines. Yeah, what's wrong with that? Mm-hmm. A, yeah, nice. New map is equal to match 16 char. Add, the key is C. New coordinate if there already exists some. Then we just concatenate it. Yeah. So strange. Dot size. No. Is there a there is an update. It doesn't really matter. T equals the to list of new underscore map in yep, print underscore int, oh actually print underscore inline string event list dot length of t, and you just do this. There we go. 0, so a1. Wait, if key was already bound in M to a value that is physically equal to data, M is returned unchanged. That's okay. We update C. Function that returns. Wait, how does that work? We can actually do this is equal to char map.update C I where match I with none. Then we go. How do I do it for? Then we return sum with not C, but the X and Y. So I and Y. Sum L. Then we return I, Y, and L. Is C in oh, it's doing this, okay. And still nothing. Wait, not here. We return ACC there. Not map. Okay, good. Nice. 5, 5. Okay, yeah, that was a little bug there. 5, 5 is wrong. Print. Okay, let's do printf.printf of I, J in. No, you just like this. That's it, yeah. Four, 3, 5. Oh wait, I didn't even check this. Oh yeah. If I go 1 there, then it does the correct thing. Great. Trust myself. Trust myself a bit more. Great. Now that we have that, where were we before? We had get anti-nodes for this, so for every one of those things in the map, we need to return the number of anti-nodes. Yeah, we've got to calculate them, and we've got to check if they're in bounds, so get character anti-nodes, takes in an M. Okay. And it should also take in a C, like a character, so let's chords equals jammap, that's find CM in. Yep. Now going to be a list of tuples. So it's for each one basically. This one, yeah, there's like a double for loop here. The way we do that is let loop node underscore list and then ACC equals match node underscore list with this, then we return ACC, else we go and we say, oh, and first x1, y1, x2, y2, get, return, get anti-nodes, let's 1 equals get anti-node, and then anti-node 2 get anti-node of next one y1 to actually let's go c1 c2 and we go loop C1, that stays unchanged. Anti-node 1, anti-node 2, added with ACC and tail. In yeah, that's it. Okay, I guess we have to be careful a little bit because we not let recursive gets all or something. That just takes in ACC and then list, which is equal to a match node list with, this is going to be very, very similar. C1 let into nodes equals, we'll actually just return get all, where they see is the loop of C1, an empty list, and the node list is going to be the tail. Yeah. Sorry, loop. Wait. So on the tail, yeah, and this with the get all. Get all ACC is going to be this added with ACC tail. In we do get all just this actually chords. Okay. So now if I do C anti-nodes equals character anti-nodes of MC in, and here we go, this dot length of C anti-nodes, return 0, get rid of you, like this. Not found, love that. Oh, we just had it though. Oh, never mind, it's an A, not a C. 2. Okay. Piped into list.filter where xi I always forget. Let y equals 1, 2, 3, y dot filter I where I is bigger than 2. Right is filter and keep only the truthy values, where x is bigger than or equal to 0, and actually let's just let valid C valid anti-nodes this dot filter x y where x is bigger than or equal to 0, x is smaller than list dot length list dot nth line 0, and y is bigger than or equal to 0, and y smaller than list.length lines. See antinodes in here. List.length let part 1 equals valid antinodes list.length in part 1. Okay, get rid of that, get rid of that. This. It sure loves to duplicate things. X bigger than when x is more than list.length. Do I have to put brackets around this? No. Lines list dot. There we go. 2. I mean that's fine. Oh yeah, but now we have to be more generic. Let all keys equals char map dot to list m, where we do list dot map fun key underscore list dot map this. Right. How's that wrong? XY or something. Key, something we don't care about. Just a key. And let part 1 for real now equals this dot fold left C C C antinodes, just antinodes, these are the valid antinodes, and then we go in and then list.length of valid antinodes, or even ACC plus that. We give it 0, we give it all keys in this. There we go. Okay. Let's see. 15. Ah, nearly. Wonder if there's something with this. And X is smaller. Oh. Right, yeah, there's duplicates. Remove duplicates equals L equals let recursive loop ACC L equals match L with I know I'm doing a lot of stuff like this, which does just mean I can do s dot left fold left ACC L actually, yeah, let's just do it the longer way. I feel like it's a little bit nicer to look at anyways. ACC L equals match L with ACC. Scene, which is char sets, yeah. If char set dot let's actually do let found tuple set. Match found with none. Then we go loop we add head CC scene is let new set equals tuple set dot add head scene in, and then we go to set tail sum underscore, we just go ACC, the scene, and then the tail. Oh wait, find option of the, oh, it's the other way around. Okay, and in loop L, loop ACC is just a list, tuple set dot empty, and then L. Okay. Remove duplicates of isn't there a, wait, how did I do this one here? And tuple set. Oh, does, because it's, yeah, it's too much for what we needed to do. Then 1 0 else 1 or something. There we go. Now we should get 14. Oh, it doesn't actually remove duplicates. That's great. Let xy equals head n. Okay. Hmm. I feel like there should be some duplicates here. What was it that I said? Because the topmost A frequency antenna overlaps with a zero frequency antinode, there are 14 total unique locations. The topmost A frequency. Not sure what it's yapping about, but hey. 11 0 2 3 9 minus 1 6 5 3 1 9 4 0 7 6 2 3 6 10 11 12 13 10 10 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. I mean, am I seeing? Maybe I'm just not looking quite right. 3 1 3 1. Yeah. Then we add it, else we don't increment anything. What happens now? We should get found once. Oh, even, sorry, no, not found. Does go with a new set, it goes with scene. Oh, wait, hold on, I'm silly. No, it goes a new set here, every time. It means that found is none all of those times. That's pretty strange. What if we do something like tuple set.toList of found, and we do like a list of length like this. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 1, 2. Oh. Well, I'm stupid. Scene goes in here. And before we even start, that scene empty nodes equals tuple set.empty. And a new scene. CC scene, and we go with new scene. Let's do tuple empty down here. That's a lot of code we've just written. Compiler seems happy. Maybe I didn't save in time. Oh, yeah. That's it. 15? No, man, come on. Surely the 3-1 has been found before. 3-1 has been found before, yep. And... this feels very, very correct, though. We're getting the... Yeah, not for sure. Here and here. That's really annoying. Because I don't know what's going on. Instead of find option, we could do mem instead. The int tuple. If found, then we can do this, we can do this. There we go. Loop applies to many arguments. Oh, it's this would need brackets of its own. I did try this before actually. That worked a little bit better. If, sorry, not found. Wait. Not get, question mark. Not operator. Oh, I just actually have to say not found. Come on. It has found it, though. If this belongs in set, bro, what? Surely, if this worked, the other one has to work too. This one was slightly, you know, bigger, but doesn't matter. So confused. Tuple set for sure takes an int tuple. Come on, man. Okay. Let exists L item equals break match L with this, then false, otherwise head tail s2 x y y2 x1 y1 s2 y2 if x1 equals x2 and y1 equals y2, then true else exists with x1, sorry, x1 tail x1 y1. Let's just do this then, and then here let found is equal to exists in scene the value of head in. If found, then new scene equals this head and ACC. No, sorry, head and scene. Scene. New scene. Okay, that worked. I don't know why, but it did. Two. Nice, good. Watching over your shoulder as you work, one of the historians asks if you took the effects of resonant harmonics into your calculation. Whoops. After updating a model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency, regardless of distance. This means that some of the new antinodes will occur at the position of each antenna, unless the antenna is the one. Wait, okay, so there's 3 T frequency antennas. Now creates antinodes. Okay. Pop. So they go in line. On there. There. Interesting. So I mean, they just kind of continue. That's fine. I do wonder. I mean, it's just I'm just gonna have to change the. Where even is it? Character antinodes, get antinode. Here, we're gonna have to change this to be just way more. Okay. This is this could be like completely brute forced. But we could also do this slightly nicer by including a y limit and an x limit. Going from one to the other. Okay, we could stop adding the ones going like to the bottom right. Let recursive loop equals an ACC. And then a multiplier equals let let's new x new y equals do this here. If let's go multiplier, if new x is bigger than or equal to 0 and new x is smaller than the x limit and new y is bigger than or equal to 0 and new y is smaller than y limit, then we go loop with the ACC being new x new y new x new y added with ACC multiplier plus 1 else ACC. There we go. We need to return like, yeah, from C1. Wait, is it? No. X, Y, X, Y. Let first chord anti-nodes. First, let's just go loop the coordinate 1. ACC multiplier starts at 2. Second equals loop. Oh, and dx dy is also kind of given. Okay. Dx dy c2 minus dx minus dy empty to in, and then we return first and second. Get antinodes, get part 2 antinodes. And I guess we could just copy this bit of code, place it as part 2, character antinode, fn, Sorry, let's do fn here. Okay. Part 1 anti-nodes equals character anti-nodes of get anti-nodes. Then we can do this here. Then we do part 2 get part 2 anti-nodes. Yeah, okay, actually we're gonna have to change this guy a little bit. Okay. So the get anti-nodes could actually return a list instead of a tuple. So it goes list here, and then that. There we go. This should be okay. Character anti-node returns a gets given a function. int list. Oh wait, it's too much. Let's do, yeah, let's do x limit, y limit, and here, yeah, we can really make use of the type system very well. So the x limit is going to be string dot length of this dot nth of line 0, and just here we're going to have this dot length of lines. Maybe, oh yeah, expression wrapped in brackets here. Oh nope. Int list. And part 2. Yeah, we'll merge those. Oh, come on, stop it. Oh. Do we do? Fair enough. You know, I didn't have the highest hopes for that. What was it here? 34. 29. Might be stopping too. Maybe we're stopping too soon. X plus the multiplier 2. Then it goes C2 and a negative. Yep. Yep. Okay. Multiplier plus 1. Yeah. Well, 29 is close, I guess. Let's try this one. 6. 1, 2, 3, 4, 5, 6. Oh wait, in fact there are the 3 rings are all exactly in line with 2 antennae, so they're all also antinodes. I think multiplier must start at 1 then. Yeah, that gives me 9. Go on, oh no. Okay, because now we have actual antinodes on nodes themselves. Perfect. Okay. Very nice. Do we have 9 day 9? So I'm a little bit behind, but I'm trying to catch up. Okay, let's just tidy up this part here. Let's write it. And part 2 antinode goes in there. Let some antinodes, which takes in a function which is equal to fold left of all keys, and it's going to do fn here, and then part 1 is just going to be sum of antinodes with the part 1 antinodes. There we go. And we still get the same answer. That looks nice as well. Cool, a lot of currying in this one. Kind of structuring my code in slightly nicer ways. Bounds checking, I could have offloaded to one function. This was annoying, and I don't know why the set stopped working halfway through. Anyways, thank you for watching. This is a day late. I will catch up at some point, but yeah, see you tomorrow.